Hi, students and friends. This is your host and teacher, Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. I'm continuing my O-level past papers session, and this time I have selected paper 42 of May-June 2024. It's a 1 hour, it's ATP, paper 4 is ATP. You know that you have to answer all the questions. You can use calculator in this paper. Notes for use in qualitative analysis are provided in the question paper. Total mark for this paper is 40. Remember, there won't be any periodic table attached to this paper. So this is the notes for use in qualitative analysis. You can use it. Anions means negative ions. Cation means positive ions. So this is the list for anions and cations. And you are also provided with tests for gases and flame test for metal ions. So let's start the paper. Here's question number 1. A student finds the amount of iron 2 ions in a solution by titration. The student uses a volumetric pipette to add 25 centimeter cube of aqueous iron 2 sulfate to a conical flask, adds approximately 20 centimeter cube of dilute sulfuric acid to the flask, slowly adds aqueous potassium magnate 7 to the conical flask until the solution just turns pink. Repeats the titration several times. 1. Figure 1.1 shows the apparatus the student uses to measure the volume of dilute sulfuric acid. Name the apparatus shown in figure 1.1. You know that's measuring cylinder. So I will write measuring cylinder. Part 2. Explain why the student does not need to use a volumetric pipette to measure the volume of dilute sulfuric acid. They have already mentioned approximately 20 centimeter cube of dilute sulfuric acid. So the volume does not need to be accurate. Volume of acid does not need to be accurate. You can even write precise, beside accurate or precise. Part 3. Describe how the student uses the volumetric pipette to measure 25 centimeter cube of aqueous iron 2 sulfate safely. Now they are talking about safety. So you'll use safety pipette filler. Safety pipette filler is used. Part B. Name the apparatus the student uses to add the aqueous potassium magnate 7 to the flask. So they are doing titration. So in this case, they have to use burette. Burette will be used for aqueous potassium magnate 7. Moving to part C. State why the student does not need to add an indicator in this titration. Now in this experiment, they are using potassium magnate 7. It's a self-indicator. So you write potassium magnate 7. Is self-indicating. D. Explain how the student knows when they have done enough titrations. You can have two results, should be within 0.2 centimeter of difference with each other. So you write two results are within 0.2 centimeter cube of each other. The difference must not be more than this. Number two, a student investigates the temperature change when a solid completely dissolves in water. The student measures 25 centimeter cube of distilled water and pours it into a beaker, uses a thermometer to measure the initial temperature of the water in the beaker, records this temperature in table 2.1 at time 0 second, adds a sample of the solid to the beaker and starts a stopwatch. Stirs the mixture and records the temperature and time at 60-second intervals for a total of 300 seconds. Some of the results are shown in table 2.1. A. Part 1. Figure 2.1 shows the results for 120 seconds and 300 seconds. Record the values from figure 2.1 to the nearest 0.5 degrees centigrade in table 2.1. Now for 120 seconds, the temperature must be 10, 11, 12, 13. So it's 13.5 degrees centigrade. So we have 13.5, 13.5 here. What about 300 seconds? 11, 12, 13, 14, 15. Should be 15. So I will write 15 here. 2. Calculate the maximum temperature change in the investigation. Maximum temperature change. It must be 19.5 minus 13. Lowest is the 13. This is lowest. The maximum is 19.5. So I will subtract lowest from the highest value. So what you will do, 19.5 minus 13. And this will be 0.5 minus 13, 6.5. Moving to next part, part 3. Describe the trends shown in the results in table 2.1. So if you look at the trend, so initially temperature, what's happening? 19.5, 13, it's decreasing. Then from 13, we have 13.5, 14, 14.5, then 15. So it decreases initially, then increases. So you'll write temperature decreases initially, then increases. Part 4. Suggest the temperature of the mixture if it is left for 60 minutes. Explain your answer. Temperature after 60 minutes. So 60 minutes means 1 hour. So what happened after 1 hour? It will definitely return to its original temperature, 19.5 degrees centigrade. So you write 19.5 degrees centigrade. The reason explanation is that it's returning to room temperature. The reaction will be ceases after this 60 minutes or within 60 minutes. So it will definitely return to room temperature. B. Describe the energy change when the solid dissolves in water. Explain how the results in table 2.1 support your answer. So if we are dissolving solid in water, what's happening here? So the reaction, it's absorbing energy from the surrounding. Or you can write endothermic. The reason is that temperature decreasing here. C. Explain why it is important for the student to stir the mixtures so that there will be even distribution of temperature when all solid dissolves. So you write ensuring even temperature Part D, the maximum temperature change calculated is not the true value for this investigation. This may be because the volume of water and the temperature are not measured precisely. Explain how to obtain a more precise temperature measurement. So definitely you have to use graduated thermometer for this purpose. Use a graduated thermometer. In this way, you will get the more precise temperature measurement. Part E, the maximum temperature change calculated is less than the true value for this investigation. Suggest a reason for this other than the precise precision of measurements. Describe an improvement to the method which reduces this error. There will be gain in heat from the surrounding. So in this case, they can use polystyrene beaker or insulated beaker for this purpose. So I will write heat gain from the surrounding. Use polystyrene beaker. Use polystyrene or insulated beaker. You can even use a lid to avoid this heat gaining from surrounding, or use lid. Moving to next question, which is question number 3. The student does a series of experiments to investigate solution R. A1, the student leaves a wooden splint with one end dipped into R for 10 minutes. The student then places a damp end of the wooden splint into the flame of Bunsen burner with the air hole open. The student concludes that R contains sodium ions. State the observation which allows the student to make this conclusion. Simply have to look at the color of the flame for the sodium ion, which is yellow. So you write yellow flame, which concludes that it contains sodium ions. 2. Explain why the air hole on the Bunsen burner must be open while doing this flame test. If you open the air hole in the Bunsen burner, what will happen? It will give blue flame, not yellow, because the yellow flame, it will mask the flame color of sodium ion. So you write to prevent the yellow Bunsen flame. as it will mask the flame color of sodium ions. B1. The student adds dilute nitric acid to R. The student observes effervescence of a colorless gas which turns lime water milky. State the conclusion from these observations. So it must be the carbon dioxide gas which is formed. It's turning lime water milky. So it must be containing what ion? If you look at the negative ions, it's actually the carbonate ion which on reaction with dilute acid give the test for carbon dioxide, which is effervescence or fizzing. So for the conclusion, we will write CO2 form. Definitely this effervescence is due to the formation of CO2. Then you write R contains CO3 minus 2. Carbonate ion. Number 2. The student adds aqueous barium nitrate to some of the mixture from B1. The student concludes that R contains sulfate ions. State the observation which allows the student to make this conclusion. So if you look at the test for the sulfate ion, here's the sulfate ion, the test with barium nitrate, white PPT. So it must be white PPT or white precipitate. So I will write white PPT. Looking at the test. Moving to next part 3. The student adds aqueous silver nitrate to some of the mixture from B1. The student observes a colorless solution. State a conclusion from this observation. Aqueous silver nitrate. So aqueous silver nitrate, this is a test used for checking chloride ion, bromide ion, iodide ion. See, aqueous silver nitrate. So no color means halide ions absent. All these halide ions are absent. So you have to write down the name of these halide ions because halogen contains other elements also. So you write no chloride or bromide or iodide or bromide or iodide ions present. This will be the complete answer for this part. Moving to next part, which is part 4. The student adds aqueous sodium hydroxide to R and warms the mixture. Describe and test observation to show that R does not contain ammonium ions. So ammonium ion, it's a positive ion. Where is the ammonium ion? Here is the ammonium ion. On warming, it must give ammonia gas on warming. It must give ammonia gas, and ammonia gas is then tested. This is a test for ammonia gas. It turns damp red litmus paper blue. So what we will write? We will write, we have to test the gas with red litmus paper and there won't be any change in color or does not turn blue. So you write test the gas produced, test the gas produced with damp red litmus paper. So observation will be no change. If it was ammonium ion, then it must be producing ammonia gas, which will definitely turn this red litmus to blue. C. Solution R is made from a mixture of two different ionic compounds. Suggest the names of these two compounds. So far, what ions we are having in this? We have sodium ion, that is Na plus, Among negative ions, we are having sulfate ion, SO4 minus 2, and CO3 minus 2. So the compound, it must be containing both sulfate and carbonate. So we have sodium carbonate and sodium sulfate. Part D. The student tests a different solution P and finds it difficult to decide whether the solution contains chloride ions or bromide ions. The student also has aqueous potassium chloride and aqueous potassium bromide. Suggest how the student could use the aqueous potassium chloride and aqueous potassium bromide to make it easier to decide whether P contains chloride ions or bromide ions. Definitely, you have to carry out the halide ions test on potassium chloride and potassium bromide. Then you compare the color of this precipitate with the unknown, which is P here. Carry out halide ions test. You can even write the test for this, which is silver nitrate, aqueous silver nitrate on the potassium chloride and potassium bromide. Then you'll compare the color of the precipitate obtained with the unknown P. Moving to next part, which is part E. The student adds dilute hydrochloric acid to another solution and a gas is produced. The gas is passed through lime water. Describe how the gas can be passed through lime water. You may draw a label diagram to help answer the question. Now they gave you the space for this one and the total mark for this question is true. So label diagram, you will be having one test tube with HCl. So you have one test tube like this. It must be solution P plus HCl and here's the solution. Then pass this gas through lime water. It must be delivery tube like that. Another test tube containing lime water. Here's lime water. So you'll be having carbon dioxide coming here. This tube must be closed so that the gas will not escape or go out. And this one is lime water. In this way, you can gain 2 marks. Or if you want, you can write the description, which is use a delivery tube. First point, use a delivery tube. And delivery tube from the test tube. Which contain P and HCl, containing P and HCl. Now bubbles the gas or pass the gas through lime water. Pass or bubbles the gas to lime water. Here's question number 4. Copper 2 carbonate reacts with dilute sulfuric acid at room temperature. The word equation for the reaction is shown. Copper 2 carbonate plus sulfuric acid gives copper 2 sulfate plus carbon dioxide plus water. Plan an experiment to determine the volume of carbon dioxide formed when a known mass of copper 2 carbonate completely reacts with dilute sulfuric acid. Your plan must include the use of common laboratory apparatus, dilute sulfuric acid, and copper 2 carbonate. No other chemicals should be used. Your plan must include the apparatus needed, the method to use, and the measurements to take, procedures to ensure that the volume measured is as accurate as possible. You may draw a diagram to help answer the question. Now, this question is of 6 marks. So, how you are going to divide your work? So, you will get maximum of 2 marks from each section. The apparatus needed, method, the procedure to ensure the volume measure is accurate. It's related to accuracy. So apparatus, very easy in this case. What apparatus? You can draw the diagram of suitable container. So most probably you have you are planning experiment to determine the volume of carbon dioxide formed when a known mass completely reacting. So what apparatus you are expecting in this? You may have conical flask. This is conical flask. Remember, label the diagram. Test tube. For collection of gas, you may have gas syringe. You may have measuring cylinder or burette. I'm labeling these. This is conical flask. This is test tube. This is gas syringe. This one is measuring cylinder. So you can draw any two from these. Now coming back to the question. Now for the method to use and measurements. So what method and measurement you are going to do? You will definitely have to measure the mass. Method and measurement. Any two from these. Measure the mass. Use excess acid. Measure volume of gas produced. Mention the name of container, use of a cork. in the reaction container. Now, in order to get the accurate result, so you can pick any two statements from these. For accuracy, you have to wait until no more bubbles produce, or for instance, wait until no more effervescence. You can even write or change in volume, because gas is produced, there must be change in volume. Change in volume. You can even write or no solid remains, or no solid remains, or carbonate has reacted. Then, for accuracy, you definitely have to repeat to take average. Repeat to take average. This is for reliability. You can even write identify anomalies. What is anomalies? Anomaly is irregularity or indefinite trend. You have to identify this during this experiment. Identify anomalies. For the method and measurement, you can even describe a method for adding acid. Describe a method how you're going to add acid for adding acid. So you have any two from method and measurement, any two, and any two here from this. In order to get an accurate result, you have to wait until no more effervescence or no more solid remains. Repeat, you are repeating to take average, making it more reliable, and identify anomalies. And then you have any two diagram from these. Any two from these. In this way, you can gain full 6 marks. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.